Alright, in this lecture I will be explaining how the central processing unit or processor works, because it's a crucial component that you need to learn how it works before starting to program in assembly. So we are not going to get too in depth of how the processor works because it's not necessary. We'll only learn what we actually need to learn. So your processor is really the main component of your computer. It does really everything your computer needs to do. It stores, executes, and decode instructions and operations in the memory. Basically, it's what executes the operations that your programs need to do in order to function properly. For example, I need to add 1 plus 1 and show the result on the screen. All of this could be done by the CPU. It's true that nowadays we have other components such as a GPU, or if you prefer a graphics card, but we don't need to know that for now. We'll only focus on the CPU. So the main component we need to understand now is called the registers. Basically, the registers are small units of storage for memory inside of your processor, because yes, the processor needs to store memory. Now, registers have each their own sections. There are multiple types of registers, but they globally all do the same thing, and that is storing memory extremely fast. It's not important that you learn them for now, but the registers all have also their own purpose because they all have a different unique name. For example, the ESP in that image on the right means the stack pointer. We'll learn what a stack is later, but they do mean something. Even though it's not important, you know that. Also, the registers depends on the size of the CPU. You know, when we say a CPU is 32 bits or 64 bits or even a program, we basically can refer to that when we talk about the registers. So a CPU of 64 bits in size will have 64 bits registers. It means that the registers will have 64 bits of size. On the image on the right, you can see that inside of, for example, EX, you have AX, AH, AL, and you can see that it burns down to 16 bits, 8 bits, and that is just because in programming, we can use those registers to store smaller and smaller chunks of memory. And it's still the same registers, it's just that they have a different name when they are smaller. Now, the registers are really just like variables in programming. They can point to locations in the memory, they can store results, they really just do the same thing as variables. Now, there's a special register we need to talk about, which is the program counter, or for short PC. This register basically stores the next instruction that the CPU will execute from the memory. Basically, while the CPU, for example, executes 1 plus 1, well, the next instruction in the memory, which is 1 plus 2, its position will be stored in that register. And once the CPU will be done with 1 plus 1, it will switch to 1 plus 2 by accessing the address stored in the PC. It's really all this register does is pointing in the memory. There are two other components in the CPU that I need to explain, which are the arithmetical logical unit, or for short ALU, and the control unit. The ALU basically is a library of instructions that the CPU will execute. To be more precise, arithmetic operations. And the CPU will, for example, when he wants to add 1 plus 1, he will go into the ALU to execute that operation. But there's another step that goes before that, which happens in the control unit, which is decoding the instructions, because the processor, once he fetches from the memory the instructions, he needs to decode them to be able to execute them after. And this process of fetching, decoding, executing, and writing back is called the CPU pipeline. And each time the CPU pipeline happens, we call that a cycle. The CPU will store the next instruction in the program counter, fetch the current instruction he's at, decode it in the control unit, and execute it in the ALU. And after that, he will obviously write back to the memory the result. And that is all you need to know for now about the CPU. Now, I jumped over some details and some not so important, like the names of the registers, because I think throughout the series, while I will be teaching you these things, how to write the code, you will get these concepts. So don't worry if you don't clearly understand them for now. Later you will. And this video is kind of a support because it's not the perfect video about the CPU. It's obviously extremely short and there's a lot more to talk about the CPU. I just presented the basic details from a extremely high perspective. So if you want to understand better the CPU, even better, I advise you to go make your own research. Though you don't have to, it should be enough for now. But with this video, you should have a basic understanding, and so if you decide to go and learn more, it should be easy for you, or easier. Now, another thing I want to add on this is all this architecture that we just saw, or more, everything I teached about the CPU, it has a name. It's an architecture that was introduced by a man of the name of von Neumann. And this architecture, as you can see on the image, it has the CPU with a control unit in it and the ALU, and also a memory unit, which will be basically the memory of your computer, like the RAM and the registers. There's also an input device and an output device, but it's not important, we understand the I/O for now. Well, thanks for watching this lecture. I hope you understand a lot now, and I'm trying to make myself better and better at making these lectures as I make them, because it's the first time I attempt to make a series, and trust me, it's not easy. But I'll see you in the next lecture.